I want to take just a couple of minutes to demonstrate the capabilities of the API. I'm going to do two things. First, I'm going to send data as tables and table updates over the wire from a publisher to a consumer, where that consumer is actually another Deephaven worker. I'm going to actually be on the receiving end of that during the demonstration. And when I receive the data, I'm going to prove that I can extend the DAG locally so that I can hear it updating data across the wire, and then, you know, in the worker that I'm receiving it, do more work to further describe a logical tree through the DAG and have all those updates propagate. And then the second way I'm going to consume the data is via a pretty simple widget that we've pushed into an iframe, so that without running Deephaven whatsoever on the consumer side, we can in a browser support a fairly simple but interactive table rendering. So let's get rid of my face and see if I can show you the goods. So here's, just for your knowledge, the barrage documentation that's out there. It's quite complete, and it also has a reference to the GitHub. This is Apache licensed because, as stated, we extend Apache Arrow's flight protocol. We essentially use their payloads to try and represent tables that change, both via appends, but also deletions and modifications, shifts, everything of that nature. So hopefully that's what you see. In this example, I've asked a colleague of mine, Devin, to go into Deephaven examples and launch an application. He essentially downloaded this image and launched an application that's running this example. I'm going to be a consumer of the tables that he produces. I'm going to inherit them over via barrage over the internet, frankly. Let's take just a second to see what he's doing on his side. On his side, he's running this application, which is doing two things. First, it's going in and it's receiving two Kafka feeds. You can see these trades and these these quotes. There's a few ways that you can receive Kafka feeds. Either where you're looking at only each stream as it comes in and aggregating it or something of this nature, or you're looking at all the partitions since the beginning. The second thing that he's doing is he's, with those Kafka feeds, he's in some cases doing logic to create a derived table, right? So he's rendering tables and producing name tables around trades and quotes, but also in particular he's doing some aggregations here so that he has a summary view of what's going on. So again, I'm not going to show you how to run that application. He's running it. It's out there in the wild right now. He is putting data out on the internet. I'm just going to show you how I can consume those tables and those table updates here locally. Again, the first way I want to do that is via a Deephaven worker. So I'm going to launch the Deephaven Docker image, the standard Docker image here. That should be done launching in just a second. Yep, that's done. And now, I could see, a number of ways I could launch a client to see data that is inherited in that server. But, the easiest way for me, and the way I like best, frankly, is typically to just run our front end if I'm just exploring data. So here I now have a front end that's connected to that server. You can see that it's empty. I'm just going to pull up a notebook to try and walk through some methods here. We've written a resolver, which allows users an easy way to get data. For example, here's the syntax to get local parquet. Here's the syntax to get remote CSVs that are available on the internet via various websites or whatever. But that's off topic. What I want to do is I want to connect to that application that Devin launched. So we have this resolver that just says, hey, he gave me the address of that application, and I want to go get the table he called trade streams. So again, across the internet, I'm subscribing to this table that he makes available. This stream table is something he's configured on his side, where he's inheriting the Kafka feed and creating a micro batching such that he's only in memory holding on to the data that came across within that micro batch. Okay, so that's why you see this in this uh, appear like it's sampling, and the number of rows are different based on how much crypto is trading during that micro batch window. Okay, this streaming process is a very good way to create aggregations without using much memory, but that's a different topic, so let's move on. He on his side has also made a table called trades latest available, right? So I can inherit that, and here we go. Now I'm seeing what are the latest trades for each exchange for each instrument, right? And I could sort that in different ways if I wanted to. Obviously, there are things I only want to look at Gemini or something like that. Okay, I can create, as I've shown before, I can use the interactivity here of the UI to interact with the table. But one question we had earlier is whether as a server that inherits tables and table updates, can I extend that logic here? Can I essentially further propagate updates through a local DAG that extends the inherited one? And the answer is yes. So all I'm doing is I'm taking that table called trades latest, and I'm adding some very simple business logic, and I'm creating a new table that's just for each exchange, for each underlying symbol, what is the notional volume in the base currency of the last trade. And it looks like nothing's traded on Bitstamp for a few moments. So that's pretty static, but you can see all these other ones are moving around quite a bit. Okay. And I can subscribe to other tables if I want. He's made a fairly comprehensive trade summary view here available, and obviously he's done other things like he's also done the same thing with quotes. If I wanted to, as demonstrated in other in other demos, I could join trades in quotes or something like that based on time, because we're very quite outstanding at handling time series as well. But I want to move on from this case of inheriting tables and table updates from a remote worker, what we call worker-to-worker connections, which are very, very powerful, to very quickly demonstrate a different way to inherit data in a local client, let's say. In this case, I'm going to inherit in a JavaScript browser client. So here Devin's made available not just the tables, but he's created a web page with a simple asset that has an iframe that then embeds a Deephaven widget in it. So now I'm not running, there's nothing locally about Deephaven that's supporting this at all. I'll shut down my Deephaven server. You'll see that this continues to run. It's because I've just launched a browser that has an iframe that's hosting this, right? So we think, and this is very interactive, just like, you would expect. I can do the same types of things that I was showing you before. Oh, I only want to see trades that, happen to have occurred on the bid last time or something like that. We think that this opens up a huge number of use cases, both, here it is embedded in an iframe, or you can see what it looks like raw, just as a HTML rendering. We think this ability to create communications between clients and servers across the internet for tables and table updates is really interesting to explore, particularly to the extent that these are, these APIs can be quite full functioning, such that it's entirely possible to move logic from the client to the server based on, as I'm doing here, based on what you're clicking, or potentially much more sophisticated things what someone might do in a widget. So we look forward to use cases where servers have huge volumes of data, or even dense volumes of ticking data, and there are elegant but very simple clients spread around the world that are inheriting that data and doing very interesting things with it. So thank you very much for your time. I hope you see the power of the Barrage API, the power of moving tables over the wire, but in particular moving dynamic tables over the wire in their full glory. Thanks very much.